Dear students, again welcome back for the third session of this particular chapter, that is solutions. Previously we have discussed how to express the concentration terms, or what are the various concentration terms with respect to a solution. That concentration is indirectly sometimes called as a strength of a solution. So that we have discussed in the form of 9 different terms, in the form of molarity, molality, normality, formality, mole fraction, parts per million, followed by last 3, mass percentage, volume percentage, along with the which one? Mass volume percentage. And then we have discussed some of the relation between the molarity and then the molality based on the density of that one. Okay? And then we are having the relation between the normality and then the molarity. So that relation depends upon its either the basicity or the acidity, or it may be the total positive charges, or it may be the number of electrons gained, or it may be the number of electrons lost, depending upon whether it is an respectively acid or a base or a salt or an oxidizing agent, or it may be a reducing agent. Okay? So that we have already discussed in the previous session. So now, as for the syllabus, we are having the concept called as only the what solutions? Liquid solutions, as far our syllabus is concerned. It is a homogeneous mixture of either a solid or a liquid or a gas in a liquid solvent. It is a homogeneous mixture of either a solid or a liquid or a gas solute that has been present in preferably the what solvent? The liquid solvent refers to the what? The liquid solutions. So based on that, we are having the 3 different types under this. The first one is SL solution, LL solution, and then the GL solution. That is called solid liquid solutions, liquid solutions, and then the gas liquid solution. The first, whatever the physical state that we have mentioned, it is a physical state of a solute, and then the next one is considered to be the what? The solvent. Okay? The homogeneous mixture of solid solute in the liquid solvent is called as solid liquid solution. The homogeneous mixture of a liquid solute in a liquid solvent is called as liquid solution, whereas the homogeneous mixture of a gaseous solute in a liquid solvent refers to what? The gas liquid solution. So for all of this, we need a term called as what is solubility. The first term that we have to be very familiar for this is what is a dissolution. What's that? It is dissolution. So what is a dissolution here? Just we are putting what to what? A solute into a solvent. During that, what happens? There is a process of dissolution of a what in a what? Solute in a solvent takes place, and that process is called as dissolution. Means just it is the process of dissolving. The process of dissolving a solute in the given solvent. It is just the process of what? Dissolving a given solute in the, or the added solute in the given solvent is called as which one? The dissolution. Okay? So that is, this solution or dissolution depends upon the 2 different factors. One is the enthalpy, or it is also called as heat change. And then the second factor is entropy change. And for this, you have to be very familiar. It's the best example for a spontaneous process. Means when I add what to a what? A solute into a pure solvent, what happens? The solute slowly gets dissolved in a particular solvent, or in the provided solvent. But it is an example for a what process? Spontaneous. Spontaneous means which can occur on its own, or with some initiation it has to take place. That is called as what? Spontaneous. That we already discussed in the class 11th with respect to thermodynamics. Okay. So here, this spontaneous process in the form of dissolution depends upon the 2 factors called as the enthalpy change and then the entropy change. First, what is enthalpy change and what is entropy change here? Enthalpy of dissolution change, and another is entropy of dissolution. So here the definition that we have mentioned in the first here, what is that? It is the change in what produced enthalpy. What is that enthalpy also called as? Heat produced when, how much? 1 mole of a solute is dissolved in excess of solvent. Excess of the which solvent? The pure solvent. What do you have to take? 1 mole of the solute. I don't know whether it is a solid or a liquid or a gas, whatever it may be. That has to be added or dissolved in excess of which one? Water, or it may be any solvent. What happens there? There occurs a process called as dissolution. So during the dissolution of a solute in a solvent or dissolving of the solute in a solvent, what happens? There is one heat change. Either it may be in heat is absorbed, or it may be sometimes the heat is liberated. That is why it is called as what changes? Enthalpy changes. So and that particular term is called as what? Enthalpy of dissolution. The second one is, it is also the same change in, instead of what? Entropy produced. What's entropy here? Actually the disorderness. It is a change in entropy produced when same. Instead of heat, if we have observed the arrangement of the particles, or indirectly that arrangement is indirectly in the form of disorderness of the particle arrangement or solute in the liquid solvent, and that is called as what? Enthalpy of dissolution. Here, for dissolution to occurs, how? Spontaneously. For what to takes place? For dissolution to occur. What is dissolution? It is a process of dissolving a given solute in the suitable solvent. So there must be a decrease in enthalpy and an increase in entropy, because that is the main criteria behind the spontaneous process to occur without the dependence of the temperature. Means the enthalpy has to get decreased and the entropy has to increase. Means it is the best criteria for the what process to take place? Spontaneous process. So here, for any process that the dissolution of process to occurs, how? Preferably the what? Spontaneously. What happens here? There must be the decrease in the enthalpy and then the increase in the what? Entropy. That is, delta H must be, delta H of dissolution is equal to negative, whereas the same delta S of dissolution is found to be the positive. So these two are the main criteria to occur for the spontaneous process in the form of dissolution, where the added solute gets dissolved in a suitable which one? Solvent. Okay. So this is the concept of called as which one? The dissolution. Okay. So next we will have the concept called as a solubility. What's that? Solubility. What is that solubility here? It is solubility is quite different from that of which one? Dissolution, or it will be the dissolving. Then what is that solubility first? Solubility. What that is? It is the amount of solute. Amount of which one? Solute added to the pure solvent to prepare 1 dm cube of its saturated solution. Because when a solute is added to a solvent, what happens? We are expecting the three different solutions: unsaturated, saturated, and then the supersaturated. If what the amount of solute needed is found to be the less as we have added in case of the solute, means if the amount of the solute that we have added to the given volume of the solvent, then that becomes a what? Unsaturated solution. If the amount that we have added is found to be more, or it is found to be in excess as compared to the volume of the solvent that we have chosen or taken, it is called as supersaturation. That supersaturation is indirectly called as the formation of which one? Precipitate. Because the excess of the solute particles get settles at the bottom, and that particular process is called as precipitation. In between these two, here the amount of solute is less as what required for the amount of the solvent. Here the amount of the solute that we have added is found to be the higher or excess as compared to that of the solvent that we have chosen. But in between we are having one. What's that? What the amount of solute that we have added is exactly required, or it is exactly dissolved in the given volume of the solvent, and that particular solvent is called as what solution? The saturated solution. Means it is just the amount of a which one? Solute that has been added to the what solvent? Pure solvent. For what purpose? Just to get exactly the how much? 1 dm cube or 1 liter of its what solution? The saturated solution. Okay. And also it also depends upon the temperature at the given or the specified temperature also we are calling. Because usually increase in temperature, sometimes it may increase the temperature solubility for solution of a solid in a liquid, but it is opposite that in case of gas and gas in liquid. Okay, so that we will discuss about the effect of factors. So here the solubility depends on one is nature of the solute and then the solvent, whereas it also depends upon the temperature and then the pressure. Usually unit of solubility is found to be the mole per dm cube or mole per liter, or SI unit is mole per meter cube. This is a unit with respect to which one? The solubility. It is similar to that of the unit as that of the concentration term, preferably the molarity here. Okay. So here the solubility depends upon the two different major concepts. One is it depends upon the nature of the solute and then the nature of the solvent. In addition to that, we can have either it may be the temperature or it may be the what? The pressure. Okay. So let us take preferably the solubility of, let us take directly we will want to the first one, that is dissolution or solubility of solid in a liquid, first case, because we know that it depends upon the factors called as which and which, either the nature of the solute and then the nature of the solvent, and also followed by the temperature along with which one? The pressure also. Okay. So let us have the first one, solubility of solid in liquid. Means what is the meaning of that here? Here the solute is solid and the liquid is a solvent. Okay. So here if a solid solute is added to the liquid solvent, what happens? What happens when what is added to what here? A solid solute is added to the liquid solvent. The first thing is some of the solid solute particles gets dissolved in the pure solvent, and that process is called as which one? Dissolution. That is the first thing that we are observing. What is that? If a small amount or the given amount of the solute is, which type of solute it is? The solid solute is added to the liquid solvent. What happens here? The solid solute particle slowly gets dissolved with respect to the liquid solvent. The process is considered to be the which one? The dissolution. In addition to that, after that, what happens? Some of the which one? Solid solute particles may collide with themselves. What is the second thing that we are observing is they get collide with the solute particles, collide with themselves, and gets separated out. Separated out. Here the process is called as crystallization. What's that? Crystallization. For the first thing is what happens? The solute particles, when they added with a pure liquid solvent, what happens? They slowly gets dissolved. The process is called as dissolution. But in the another case, what we are observing, some of the solute particles, they get collided with the another or the neighboring solute particles, such that they get clearly separated instead of dissolution. And this separation of the solid particles with the neighboring is considered to be the process called as which one? The crystallization. But at a particular certain stage, a state of equilibrium is reached. Means there occurs a equilibrium between the dissolution and then the which one? The crystallization. That is, solute plus solvent gives rise to solution. So this particular solution is considered to be the what solution? The saturated solution. That particular equilibrium referred to the which one? The saturated solution. That is means any excess of the solute that we have added, what they will do? They remains undissolved. That undissolved concept is considered to be the what? The process called as dissolution. Whatever the solute that we have added, which gets dissolved, and the process is called as the dissolution. In between those two, what happens? A dynamic state is reached where the rate of dissolution of a solid solute particles in the liquid solvent is exactly equal to the rate of crystallization of the same solute particles in the given solution, and that particular stage is considered to be the what solution? The saturated solution we are calling. It is the saturated solution. So here in this, during dissolution of which and a which solid in a liquid, what happens? Increase in temperature increases the solubility. If it is endothermic in nature, means if the dissolution is found to be the what in nature, or the solubility is found to be the what in nature, endothermic means increase in temperature always increases the solubility. Whereas, so during the same concept, the decrease in temperature increases the solubility if it is what thermic? Exothermic. It is indirectly the principle with respect to LCP. What is that LCP here? Le-Chatelier's principle. Usually, high temperature favors what thermic? Endothermic. High temperature means we have to increase the temperature. Means if the process of dissolution is found to be, or if the process of solubility is found to be the what? Endothermic, what happens? Further increase in temperature again increases the which one? The solubility, or it may be the dissolution. Whereas, if the process of solubility is found to be the what? Exothermic in nature, what we have to do? Exothermic means heat is liberated. Heat is liberated means we have to decrease the what? Temperature. Therefore, decrease in temperature increases the solubility if the process is found to be the exothermic, that is during the dissolution of which and a which? The solid in the liquid. It is not concerned with respect to the either the liquid in liquid or it may be the gas with the liquid. It is strictly for only the solid in the liquid. Means, what's the effect of temperature here? It is a which one? The increase in temperature increases solubility of solid in liquid if the process is endothermic, whereas a decrease in temperature increases solubility of a solid in a liquid if it is found to be the what thermic? Exothermic. So that makes a clear distinction that it is indirectly the application with respect to what principle? The Le-Chatelier's principle. Okay. So here, The solubility of solid in liquid has no effect on which one? The pressure. Means the pressure has no effect for which and which? The solid in the liquid. Because solutions exert the less pressure as compared to that. Solid solute particles exert the less pressure, or it doesn't have the collision with respect to the walls of the container, means we can't expect the pressure effect with respect to the solubility of which in which? Solid in the liquid. Means we are having only the what? The solid solute in the which one? The liquid solid. Okay. Suppose if the solute is found to be the what? Ionic in nature. The solute is what in what? Ionic in nature. If the solute is an electrolyte, if it's an electrolyte, what happens? The solubility is decided by its lattice enthalpy or lattice energy also. Lattice enthalpy, or it is also called as a lattice energy. What is lattice energy? It is the amount of energy released when 1 mole of an ionic compound or an electrolyte is completely dissolved in aqueous solvent, or indirectly it is a process of formation of 1 mole of a solid compound from its gaseous ions. Means it is the amount of energy or the heat released when 1 mole of an ionic compound, indirectly the electrolyte is formed from its gaseous constituent ions, referred to the which one? The lattice enthalpy. So here we are having the two different things. What's that? If it dissolves and doesn't dissolves, if the electrolyte suppose dissolves in water or any polar solvent, preferably polar solvent, then what's the condition here? Enthalpy of hydration, or in general it is called as a solvation, must be greater than enthalpy of that particular substance, enthalpy of formation of that particular substance, or indirectly that formation of that particular substance is indirectly in the form of which one? The lattice. It is strictly applicable with respect to what? If it is an electrolyte. Okay. Similarly, if the electrolyte doesn't dissolves in the polar solvent, then it is less than that of this. Means when the electrolyte readily dissolves in the polar solvent, when if and only what? The enthalpy of hydration or enthalpy of solvation is higher or greater compared to that of what enthalpy? Lattice enthalpy. Suppose if the same electrolyte is partially or less soluble in water, then what is the condition? The enthalpy of hydration or the enthalpy of the solution is found to be less as compared to that of which one? Enthalpy of the lattice or lattice enthalpy. So here dissolution of or solubility of a solid in liquid is based on the concept like always likes the like. This is the main principle behind the solubility of which and which? Solid in the liquid. What is the meaning of that here? Like always likes the likes. That is, polar solute dissolves in polar solvents. Similarly, non-polar solute dissolves in non-polar solvents. Usually what generally mentioned as like charges gets repelled and unlike charges gets attracted. But here in case of the chemistry with respect to what is concerned, solubility is concerned. like charges will have the attraction towards the solubility. Means the polar always attracts the polar. Non-polar always attracts the non-polar. Means like always likes the which one? Likes. That is, polar solute, the solid solute dissolves in the polar solvent, but not in non-polar solvents. Similarly, non-polar solute dissolves in the non-polar solvents, but not in the polar solvents. Means we can have the dissolution in the concept that polar always with polar, non-polar always with non-polar. But polar is insoluble with respect to non-polar, and the non-polar is again insoluble with respect to polar. So that is the main criteria with respect to what in what? The solubility of a solid in a which one? Liquid. Okay. So that is the concept behind the solubility of which in a which, the solid with respect to the which one? The liquid. Okay. So let us have the next in the form of the solubility of the second one, gas in the liquid. Solubility of which in a which? Gas in the liquid. So let us have the next one, that is solubility of a gas in a liquid. Means the solute is gaseous in nature and the solvent is found to be the liquid nature. Usually, most gases usually dissolves in the liquid solvent to a either smaller or larger extent. Usually, most of this one, which one the gases are usually soluble in the liquid solvent, either it may be in a smaller extent or it may be the larger extent. And this is decided by its absorption coefficient. Absorption which one? Coefficient. Means who absorbs who here? Gas has been absorbed by the liquid. Means the gaseous solute is absorbed by the which one? The liquid solvent. So it is the volume of the gas V dissolved in the given volume of the liquid solvent. So here the gaseous solute at capital V at an atmospheric pressure or at a pressure of so this is the definition with respect to which one? The absorption coefficient. What is that? It is a volume of a gas acting as a solute that has been added or dissolved in the given volume of a solvent. Means capital V volume of the solvent, and it is having a certain pressure, and that a pressure of what that is P here. That is mathematically alpha is equal to small v divided by capital V into P. What is that? It is the absorption coefficient into P. So here what is small v? Small v refers to which one? The volume of the gas acting as a solute. What is capital V here? It is the volume of the liquid solvent. Capital V refers to the volume of the liquid solvent at a given pressure, that is called as the given pressure, preferably the atmospheric pressure we are calling, and that particular concept is called as what constant? Absorption coefficient. Higher the value of alpha, more is the volume of gas that has been dissolved, and hence more is the solubility of gas in the liquid. It depends upon what? More the volume of the gas that has been dissolved, means higher the value of absorption coefficient, means more is the what dissolved? The gaseous solute that has been dissolved more is the solubility of that particular gas in the liquid. Okay. So here this solution or the solubility of a gas depends on the three factors. One is nature of the solute. Nature of the solute along with the nature of the solvent. Nature of the solute and then the solvent. Then we are having the temperature. Then we are having the pressure. So in case of what? Solid, in liquid, what we have mentioned? It depends upon the nature of the solute and then the temperature, but not the pressure effect. But in case of the solubility of a gas in a liquid, it depends upon the what? First, nature of the solute as well as the solvent, and then the temperature along with which one. The gaseous solutes which are chemically reactive have higher solubility in the liquid solvent than the non-reactive gases. Non-liquefiable gases or non-reactive gases. In the next concept, we will have the liquefiable gases and then the non-liquefiable gas. Means if I apply the pressure, means what happens? Some of the gases gets liquefied, that will have the more solubility with respect to the same liquid solvent. But in general, the gaseous solids which are usually chemically reactive has the more solubility than that of the non-reactive gases. For example, ammonia, sulfur dioxide or carbon dioxide are more soluble in water as compared to that of either the nitrogen or the helium, or it may be the hydrogen or it may be the methane. Why? Because NH3, SO2 and CO2 are found to be soluble in water, soluble in liquid solvent, preferably they are found to be the reactive also. But nitrogen, helium, hydrogen and methane, they are the best examples with respect to the non-reactive gases with respect to the liquid solvent, for example the water. Means the solubility of a gas in the liquid depends upon the factor called as which and which? The solute and then the solvent. Let's have the temperature. Usually, decrease in temperature increases the solubility of which and which? Gas and liquid. Usually what we have mentioned in case of that, there are two options there. What is that? Usually increase in temperature increases solubility of a solid in liquid if the process is found to be endothermic. Decrease in temperature increases solubility of the solid in liquid if it is an exothermic. But in case of the gas in liquid, decrease in temperature always increases the which one? The solubility. Because the gas solute plus liquid solvent gives rise to solution. Here the value of delta H is always found to be the negative. Dissolution of the gas in the liquid is always an example for a exothermic. Due to that exothermic, what happens? And also there is an existence of what? Equilibrium in between. Then according to the what principle? Le-Chatelier's principle. As it is only the exothermic, means it has to favor only the low temperature. Means decrease in temperature always increases solubility of which and which? Gas in the liquid. Okay. So next we will have the effect of which one? Pressure. What is the effect of pressure here? Increase in pressure increases the solubility of which and which? The gas in the liquid. As if we know that. If I apply the pressure to that one, what happens? The most amount of the gas gets dissolved in the liquid solvent. Means increase in pressure always increases the solubility of which and which? The gas in the liquid, which depends upon the what coefficient? Because increase in the volume of the gaseous solute increases the first what coefficient? Absorption coefficient. As the absorption coefficient increases, means the solubility of which and which gets increased, gas in the liquid goes on increased. Okay, so this is about the solubility concept with respect to the solid in liquid and then the gas and the liquid. So there in solid and liquid, it depends upon the nature of the solute, whether it may be an electrolyte or it may be the non-electrolyte, and whether it is an exothermic or it may be the endothermic. Therefore, it is dependent upon the temperature either directly or it may be the inversely. Directly means if it is endothermic, inversely means it is exothermic. Suppose if it is the nature of the solute, usually if it is particularly the electrolyte, usually the electrolyte which gets dissolved in a suitable solvent means it is having the higher hydration enthalpy compared to that of which one? The lattice enthalpy. If the electrolyte doesn't dissolve in the water or the aqueous medium, means the hydration enthalpy is always less than the what enthalpy? Lattice enthalpy. But the pressure has no effect for the solubility of which solid in the liquid. But to express the concept in the form of which one? The solubility of a gas in a liquid, it depends upon the nature of the solute along with the solvent. Then it depends upon the temperature along with the pressure. Okay. So this concept of solubility of a gas in a liquid is clearly explained by one law, and that law is called as which one? Henry's law. Okay. So this concept of Henry's law to describe the solubility of the gas in the liquid by which one? Henry's law. Okay, so that concept of Henry's law that we'll discuss in the next session of this particular solution chapter. Okay, so thank you.